Why do the beaded necklaces with 10 and 20 beads change color every 5 beads? And why, in turn, do 50 and 100 bead necklaces change color every 10? The colors are very important for us. We must have it very clear that as a final objective, we have the requirement to help the student be able to calculate without counting. This has a very early stage, which is that the student learns to find numbers on the necklace without counting the beads one by one, correct? This is the reason that with a 10-bead necklace, and similarly with a 20-bead necklace, we place the beads 5 by 5 so that when we ask them, for example, to locate the number 6, they don't count 6 beads, but rather say, the first 5 are one color, and then I have to count from the first color change one forward. Or if I am asked to locate bead 8, what I do is I focus on 10, which I know where it is without counting because it is the second color change, or the last, or the final bead if I am using a 10-bead necklace, and go backwards 2. This would be organizing, locating numbers on the necklace without having to count. Obviously, we do count some numbers, but we do make significant use of the necklace structure and specifically of the color changes. This will be fundamental so that later, when a student has to add 73 plus 8, they have fully internalized that 73 plus 8 means jumping 10, and that jumping 8, which is the same as jumping 10 first, and then backwards 2. That is why we assign so much importance to colors. But when the necklace has 10 beads, we do it in base 5 to associate with hands. And recently, we passed from the necklaces to 50-bead and 100-bead necklaces, where the color changes happen by the 10s, correct? It must remain very clear that our change of color has a very important long-term objective, but a teacher must already clearly understand this from the beginning. We could use, and there are people that do this, necklaces where the first 10 are one color, the second 10 are another color, and the third 10 are a third color. But it is absolutely unnecessary because what interests us is change and not any specific color. The truth is that we can return and use the first color. Yeah? We have to be very clear that the color changes invite the students to not use counting, but we cannot be certain that they are not counting one by one. And it is for this reason that, at times, we use the strategy of putting a cloth on top, a handkerchief, on top of the necklace to ensure that they do not count it. And this, in the notebook and in the platform, appears, let's say, recreated as a tunnel. What one attempts to avoid is counting one by one, and that we can be sure that the student has not counted one by one. Because there are children that count without touching, and due to this, sometimes they can trick us a little bit. We believe in them not counting it and instead doing it. Therefore, we have to have our itinerary in mind with respect to the use of the necklace. We start with manipulative necklaces, these necklaces that we make with beads and string, right? We have this, that is our first contact with the number line. Then we go a little bit more abstract and ask them to work not only with a necklace that they can touch, but also with a necklace represented in the notebook. But the representation is so faithful that the step they have to take from touching to working on the register it's a very short one. After having worked a lot with representations of the necklace on the notebook, what we do is we invite them to zoom out, to see the necklace from very far away. And therefore, they do not manage to distinguish bead from bead, but they see areas, a whole green zone, all yellow zone, all green zone, and so on. Yes, this is what we call the bicolor line. It is a line where there are pieces of the two colors that we have chosen. We identify the color changes as changes of tens. After working with this as well, our next abstraction step is going to be to give them a line that only has the 10 by 10 marks. But there's no color change anymore, okay? Everything appears in the same color, but the changes of tens are indicated. And the last step is the fact that the line already appears without even noting the tens change. Why do we go as far as this abstract version? Our ultimate goal is for them to use the number line as an instrument to think and to communicate. For this to be possible, it has to be extremely simple, because if it is a complex thing that we require to be super straight, if we require that the marks be perfectly equidistant, the difficulty of building it will be so great that we will have two solutions. One is to always provide them a photocopy version, or the other is that it takes 25 minutes to make a number line. And that is not the idea. I would like for a student, when I ask what is 73 plus 18, I want the child to draw a line, to place 73, and do jumps. If the jump of 10 and 8 are not in the correct proportion, then I don't care, because the only thing that matters to me is that the number line is there to help, to register what the child is thinking. They thought of a jump of 10 and had arrived at that number. You make a jump of 8 and you arrived at this other number. Therefore, we are interested in a very simplified model. But to arrive at this very simplified model, and so the student thinks when they look at this line, on this line that has no mark, in the background, even though I do not see them, it may have 10 by 10 marks. These marks of 10 by 10, although I do not see them, may be representing a green piece and a yellow, a green one and a yellow one. Even though you don't notice it, there are some little beads drawn on the back. And although I can't see it, in reality, I'm thinking of the manipulative model. We help the student with all this abstraction, so they feel like we're there for them through the whole process. Why is the number line empty? It's important to reiterate this idea because it's key. We can say, we want children to use the line as support to help them think. If what we really want is that the children are always able to place the numbers in the way that works for them. And a completely empty line means that if I ask them to add 25 plus 8, they can place the 25 wherever they want. You can imagine that it is about halfway between 20 and 30, but you can put a mark on the line to say, start here. And from here, I take a jump of 8. Then, following the idea of jumping through the 10, what I do is first a jump of 5 and then a jump of 3. But the only important thing here is the order. We have 25. Then after that comes 30 and then 33. I don't care if the students do the addition on the left or the right, and I'm not interested in the jumps as long as 5 and 3 are proportionally correct. And that's not the goal. The fundamental goal is that I am not working on measurement now. If I were working on measurement, this would be a goal. But now what I am doing is simply a register of what I am thinking. And I am thinking about movements along the chain that I can manipulate, and this is simply an abstract register of how I manipulate them. What potential does the empty number line have beyond lower primary? In lower primary, we rely exclusively on the 0 to 100 range. But the idea is that we want to take it much further than that. We think the number line is a model that has a lot of potential. So much so that in middle primary, when the students go into the 3rd and 4th grades, it will immediately extend to the right so that we can work in the range of 0 to 1,000 or 0 to 100,000. It doesn't matter. The process is exactly the same. You can't imagine having 1,000,000 balls, but if we have already done a good job in the range of 0 to 100, extending this concept to the right will be very easy. Right? When we are in upper primary, when the students are working with decimal numbers, we will use this line again, but this time not to extend it to the right, but to extend it inwards. So, knowing that between 1 and 2, we have 1.5, we have 1.8. And so we can ask them to do sums, jumping on the number line, but now with decimals. An example would be to ask, what is 9.8 plus 0.15? And the idea is that we place 9.8 between 9 and 10. And from there, we jump 0.1 or 0.10, and we're not going beyond 10. We're still going to be between 9.8 and 10. We come down to 9.9, and from there, a final jump of 5 cents, or 0.05, which will leave us with the answer 9.95. The strategies we follow will be exactly the same as the ones we are following with addition of numbers in the 0 to 100 range, but now we do it with numbers in any range, but also including decimal numbers. And it doesn't end there. Even in ESO secondary education, students can use this line. What happens is that now it extends to the left and it includes negative numbers, and we can jump forwards and backwards to include positive and negative numbers, which is very important knowledge and is required in the curriculum. So we know that all the time we spend in lower primary on the number line at the beginning of the student's education is time well spent in the long term as well. We believe strongly in the student's potential to work on the strategies of these initial addition strategies, but we know that all of this effort we dedicate to it will be rewarded when we can continue and extend it as we progress through the years.